Good afternoon, everybody. Welcome to Tibbetts Physics. What is crappin'? Today, on this beautiful fall day where it's snowing outside, and I'm stuck here making videos for you guys. Just kidding. But seriously, I am. We're going to look at how to analyze an object when you throw it straight up in the air. So what we got here is, you throw a pumpkin straight up in the air with a velocity of 20 meters per second. So this Albert Einstein pumpkin goes straight up in the air, and we threw it with an initial speed of 20 meters per second. And what we want to do is figure out how high it went, how long it takes to get to the top, the total time it's in the air for, and the final velocity. So let's analyze this picture. When we throw things straight up in the air, we're going to look at just the going up part at first, and then afterwards, the ball also goes, or the pumpkin, goes straight down. So let's look at going up. We know the initial velocity is 20 meters per second. At the top, due to gravity, the ball is going to stop. So the velocity at the top is 0 meters per second. And then also look on the right side too, it's also 0 meters per second. Vtop, 0 meters per second. And we know the acceleration due to gravity is g, negative 9.81 meters per second squared. So how high did it go? What we want to do is look at our reference table. And let's look at what has distance, initial velocity, acceleration, and Vtop. Since we're splitting this problem in half, this Vtop is also the final velocity for the time being. So distance, Vf, Vi, and A. That would be Vf squared equals Vi squared plus 2AD. So to figure out how high it went, part A, Vf squared equals Vi squared plus 2AD. Again, for the time being, the Vf is 0 since it's at the top. We're solving for D, so we have negative Vi squared negative Vi squared over 2a is equal to d. Plug and chug, negative 20 meters per second squared over 2 times negative 9.81 meters per second squared gives us a distance of 20.4 meters. Okay. Part B, how long was it in the air for? So now we still know Vi, Vf is Vtop, and A. What can we use to find the time? We're going to use this formula, Vf equals Vi plus At. And remember, this is the time to get to the top. So Vf equals Vi plus At. Vf is 0. Solving for t, so negative Vi over A equals t. Plug and chug. Negative 20 meters per second over negative 9.81 meters per second squared equals the time, and we get 2.03 seconds. Okay, so that's the time to get to the top. Sweet and spicy tea. It's pretty good. Alright, part C. What is the total time the ball is in the air for? Well, we throw the ball straight up, and then it comes right back down in the same exact spot. So if it takes 2.03 seconds to go up, it's going to take 2.03 seconds to go down. So the total time is just double the time to get to the top, which is 2.03 times 2. And that gives us 4.06 seconds. Okay, last part. What is the final velocity? Well, we threw it up with at a speed of 20 meters per second, velocity of 20 meters per second, sorry. And it goes straight up, and it comes straight back down. Again, it lands right in your hand. So the pumpkin is going to have a final velocity of negative the initial velocity. So Vf is equal to negative Vi, which is negative 20 meters per second. And that's how we analyze throwing a ball straight up in the air. Judging by the amount of snow we got outside, it's time for me to make a snowman. So I'll see you next time. See ya.